Let's look at the reciprocal trig identities. First, a reminder of the reciprocal trig functions and their definitions. Here they are, and a trick to remember which is by using the third letter. So sec x is 1 over cos x, cosec x is 1 over sin x, and cot x is 1 over tan x. Really useful if you use the third letter. Now the identities and how to derive them in the exam. So first of all, we know that tan x is equal to sin x over cos x. Now, because cot x is 1 over tan x, that means we can also flip that identity upside down to get an identity for cot x. So what we're saying is cot x is this flipped upside down, reciprocal, and that would be cos x over sin x. So that's the first new identity that you can either learn or learn how to derive. Next, we know that sin squared x plus cos squared x equals 1. So if we divide that identity through by sin squared x, we're going to derive another identity. And that identity is 1 plus cot squared x equals cosec squared x. And again, that's a new identity that you can either memorize or learn how to derive. For the last one, we're going to do something really similar, but instead divide through by cos squared x. When we do that, we get tan squared x plus 1 equals sec squared x. And that's the third new identity there. Now let's look at some examples. Example 1, prove sec squared x minus cosec squared x is identical to tan squared x minus cot squared x. For this proof, I'm going to start on the left-hand side, LHS for short, and I can see they've got sec squared x. I'm actually going to go ahead and replace sec squared x with tan squared x plus 1. So now sec squared x has become that. I'm going to replace cosec squared x with 1 plus cot squared x, and then I'm going to expand and simplify. So we get this. The ones cancel, and we're left with just tan squared x minus cot squared x, which is the right-hand side as required. Example 2, solve this equation, give your answers in terms of pi. Now for this one, you can choose to replace either the cosec squared or the cot squared. It's up to you. I'm going to replace the cosec squared theta with 1 plus cot squared theta, using that second identity. 1 plus cot squared theta plus cot squared theta equals 3. And again, that's just me replacing the cosec squared theta with 1 plus cot squared theta. When I tidy that up, I get 2 cot squared theta equals 2, which means cot squared theta is 1, and therefore cot theta is plus or minus 1. To solve this, I'm going to flip it upside down and say tan theta is therefore plus or minus 1, and then we're going to solve both of those separately. Let's start with tan theta equals 1. Solving this gives theta equals pi over 4 for the initial solution. Then we can draw a sketch to find the others. 2 solutions here, one there, one there. That first one must be pi over 4, which means the second one is 5 pi over 4. Then tan theta equals minus 1. Theta equals minus pi over 4. Another sketch, includes some negative this time. Go across, find the solutions that we want. So that one was our negative pi over 4. And then these two are the ones we actually want because the range is between 0 and 2 pi. So that would be 3 pi over 4 and 7 pi over 4. Final answers. 4 valid solutions for theta, and that is pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And that's it. That's it for now. If you found this video useful, please do remember to like, comment, and subscribe to my channel if you haven't already. And do share this with anyone else you think might find it helpful. Thanks, and see you next time.